mathematicians, you found this morning on your desk a brand new Volume 2 activity book. Okay, this means that we are officially all done with our Volume 1 activity book. Okay, so when we go to recess today, you can put that Volume 1 activity book in your backpack to take home and do with it what you will. Okay. We are still going to work out of our Volume 1 homework workbook for this week. And then next week we'll start with our new homework workbook. Yes, Naya?
Can I stop my hair?
Sure. So today we're actually going to skip Unit 5, which is the first unit in the activity book, which is about measurement. We'll come back to it if we have time. And we're going to turn to page 211.
What?
And 211 is about fractions. So guys, this is just like in the library when someone's reading to you. When the teacher's up in the front talking, not asking you questions to respond, you're quiet. Keep your thoughts and comments to yourself. Okay? All right. So I'm going to introduce to you today something that you may not have heard of before. But first, I need to ask, does anyone get a little scared when they hear fractions?
Yes.
No, a little bit. Some of you, okay. Kind of like dividing, right? Maybe when you heard long division, some of you got a little scared.
Yes.
Okay. I love fractions because fractions to me are like kind of going back to kindergarten, in my opinion. Because we're going to get so basic and that you'll see how easy fractions are. Okay? So I'm going to wait till everyone's really still and you got your book out.
Oh, this is cool.
All you need is your book and a pencil. Naya, any chance you can close your desk? Your book and a pencil. And Adiba, you can listen along also because fractions are so easy. Okay? So I know that you're going to go see Ms. Jennings, but you can also work with us with fractions while you're here. Okay? For sure. Okay. So can I have a volunteer to read the top of this page, 211? Mohammed, will you read it? And while Mohammed's reading, I want you to notice that they have already highlighted the important vocabulary words for you in yellow. Okay? All right. So you guys are just following along, kind of thinking about this while Mohammed's reading. So Harper, can you kind of do both, listening too? Okay, Mohammed, take it away.
A unit fraction represents one equal part of a whole. A unit fraction has a number of ones. A unit fraction 1v is one of the equal parts. The fraction bar below is divided into 6 equal parts, or 6. Each part is one of 6 equal parts, or 1/6.
Perfect. So, a unit fraction, that was a lot of language, right? What it really means, which makes fractions sound kind of complicated.
No.
In reality, keep your comments to yourself. You can go, Adiba. In reality, fractions are so simple. This is just saying I have one of something. So let's say I have one cat, or one dog, or one apple, or 1/6. It's just one of something. Okay? And in this case, it's not a whole. When we're talking fractions, we're talking about a part of a whole. Okay? And a unit fraction is magical just because the unit, the numerator is always 1, which means we just have one part. That's all a unit fraction is. It's always one part. Okay, so the numerator on a unit fraction is always going to be 1. 1.
Oh, that's easy.
So it could be 1/4, 1/12, 1/7, 1/20. It's always just going to have one part. Yes, Lawson?
So like it would be like I read 1 out of 6 books if it was
Yeah.
6.
Like you have a series of 6 books and you read one of them. Yep. That would be a unit fraction, 1 book. It could also be, I I have this big book and I read 1/6 of the book. Right? Which means I didn't read a whole book, but I read part of the book. Yes. Yusuf.
Is it 1/6? Because like, if like in these boxes, I guess it can't be like 2 boxes. It's all. Wait, yeah, that doesn't make sense.
So let me show you something. These are fun, and you'll get to have these in your hands soon. So these are fraction bars, okay? So this is like one whole. So pencils are down, you're looking at the TV. So you can pretend this is one of anything. This can be one candy bar. I like to think of it as a candy bar because it's kind of shaped like a candy bar. My favorite Snickers, it kind of looks like this, okay?
I love Snickers too.
Now I could take this one whole and I can split it into 2 parts, right? And then I would have 1/2 and 1/2, right? But do you see that when I put them together, we remember how we've been talking in our drops about equivalent fractions? Do you see how 2 halves would be equivalent to 1 whole? It's like the same. If I ate 2 halves of my Snickers bar, I would have eaten the whole thing. Now I can chop this same candy bar into 3 parts, right? And you'll notice that the numerator on each of these pieces is 1 because each one of these pieces is it's a unit fraction. Each one is a unit fraction. Whenever you see a 1 in the numerator, it's a unit fraction. Yes, Julian?
Will you have a 4?
Yep, I can cut this candy bar into 4ths. I can cut this candy bar into 5ths. I can cut this candy bar into 6ths.
7?
I don't have 7ths, but I do have 8ths.
But it's rainbow.
And I don't have 9ths, but I do have 10ths.
Oh my god.
And then if I wanted to cut my candy bar into itty bitty pieces, I could cut it into 12. Okay? Now, when we start adding these together, this is why I feel like it kind of takes me back to kindergarten. When you start saying, even if you use the smallest fraction, the biggest number, and we look at 12s, we can say, oh my gosh, if we add all these together, we have 1 plus 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 1 equals 12 twelfths or 1 whole. So we can break every fraction down into the unit fraction and take us right back to kindergarten when we were doing 1 plus 1 equals 2. Right, here you go. 1 plus 1, right?
Oh, I see.
So it's really pretty simple when you think about fractions as part of a whole. So that's what Mohammed told us up here, is that a unit fraction always has, so this is 1/6, a unit fraction always has 1 in the numerator. The denominator can be any number, depending on how many parts you're cutting your whole into. And so because it could be any number, they just use D as a variable. Because they're saying your unit fraction can be 1 over anything. 1 over 6, 1 over 12, 1 over 2,000.
Number 8.
Any number you want to choose, you can put in there as the denominator. Yes, Brandy.
I wanted to say, when you're plussing,
Adding?
yeah, I meant adding. You don't add the denominator.
Oh, you're moving on. Because this is like, you guys, it's going to be so easy. So, look at this.
If we added the denominators, then we would have more parts.
How do you know that I didn't even teach it to you yet? Brandy. It's like common sense a little bit, huh?
We had this like substitute paper.
Yay! You've already previewed that. I forgot. So here we go. Okay, I can't hear you. You're shouting out at me.
Yes.
Liam.
I think I did this in, I think it was third or third grade. Like if you're like really smart, you could like start adding fractions.
Yes, like a challenge. Yes. You got a preview and then you realize, oh my gosh, it's so easy. Okay, so let's read this part. It says, a fraction is the sum. So what operation do we think of when we think of sum?
Multiply.
Add, subtract, multiply, or divide?
Divide.
10 does.
Add.
Add. Whenever we think of sum, we think of add. Put your pencil down, Lucas. So a fraction is the sum of unit fractions. Okay, so this takes us back into like first grade when you were decomposing numbers. Does anybody remember when you would say like 1, 2, 3, 4 equals 4? And then you could say, oh, I could do 1 plus 3 equals 4, right? Or I could do 2 plus 2 equals 4. Okay? Put your pencils down. Drop them. So, this is how simple we're getting. We're just talking about fractions because that's what fourth graders do. So we already know that the fraction nd is the sum of n copies of d, which means the numerator is n, the denominator is d, the number of units in the fraction over the number of equal parts that make up the whole. Okay, that's a lot of words that basically says if we have a fraction like this, 5/6, which would look like this, we know that we could break it into 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, right? Which is what they've done here.
Just 5 times 1.
Okay? Right? Keep it in your head, your ideas. Now, you learned this in fast forward to second grade when you started learning multiplication. And you said, oh, if I have 1 plus 1 plus 1 plus 1 plus 1, it's the same as saying 1 times 5.
I learned times in third grade.
Keep that to yourself, please. So I can do, instead of 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, I can do 5 times 1/6. Easy peasy. Thumbs up if you think this is easy peasy. Okay. So you are not going to fold your fraction strips. I think you guys can see this. We've worked so much with fractions already. And you've already told me how easy it is. So look what you have in front of you here, 1 through 7, easy peasy. And Brandy pointed out a great point. She said, when you're adding 1/3 plus 1/3,
You don't add the denominator.
you don't add the denominator. It's just 2/3. Just like if I said, if I added 1 dog plus 1 dog, I end up with 2 dogs.
Why would you add?
All right, so I'm going to give you about 30 seconds to do 1 through 7. Ready? Pencils ready?
30 seconds.
Arabella, where's your pencil?
Me and Lucas something.
Ready, go.
I'm done.
Cool. In fourth grade, unlike kindergarten, you don't have to shout out when you're done.
Can I see one of
I'm going to give you about 10 more seconds. Then we'll check it. Thank you for waiting quietly, those of you who are done. Looks like we're just waiting for maybe a couple more people. All right, let's check. 1/3 plus 1/3, what did you get?
2/3.
Number 2, 1 plus 1 plus 1 plus 1 plus 1, what did you get?
5/8.
Number 3, what did you get?
1/2.
2/4, or, which is, so Yusuf says, I got 1/2 because 2/4 is equivalent to 1/2. I can divide the denominator and the numerator by 2, and I would get 1/2. Yes, Zala?
I also noticed that the 1, 2, and the 4 are the same size.
Yep, they're the same. That's when we say they're equivalent. Because they're not equal, they're not exactly the same, right? This one is 1 piece and this one's 2 pieces. But if I ate this one or I ate this one, I would be eating the same amount, right?
Both of those together.
And we always say, we don't say, this one is the trickiest fraction because we don't say 1 tooth. We say, which some kids, it's because you're saying 2, right? 1/4, 1/3. We say 1/2. Okay. All right. What did you get for number 4?
1/4.
1/4.
4/6.
1/2.
And what did you get for number 5? 2, 3, 4, 5, 6. 6/12, which is also equivalent to 1/2. So that means if we had 6 of these,
Wait, 1/12?
oops, 1/2, sorry. If we had 6/12, it would be equivalent to 1/2. Okay, what did you get for number 6?
8/12.
8/12.
7, 8.
And what did you get for number 7?
7, 8. 7, 8.
Did anyone get 100%?
Yeah.
All right, see, told ya.
Because it was way too easy.
All right.
Okay, that was tough.
So,
What is it?
Against the law to be 4th graders. Yeah.
I feel like we're going to go on to the next part.
I don't.
Oh, actually, let's take a moment and look at this page, number 212. So, you'll notice that this looks a lot like... Ah, these look a lot like our unit bars. They're just printed on paper, right? So, and they're laying sideways instead of up and down. So you can make some observations about what you see here. We've got halves, thirds, fourths, fifths, sixths, sevenths, eighths, ninth, 10, 11, 12. Okay. So, number 8 says, describe at least 3 patterns you see in the fraction bars below. Brandy, you're not looking at the right page.
Oh, yeah.
We're looking at this page. Okay. So take a moment. Ooh, Stella's writing something. Stella, what pattern did you notice?
That all of them are equivalent to 1.
All of them are equivalent to 1 whole. Great minds think alike. Did you want to write that one down, Julian, or do you have another one?
Oh, I was going to say all of them are equivalent to 1 whole because
That's what Stella said, yeah.
and 1/2.
Mm-hmm. What?
And 1/2.
And 1/2. Tell me more.
Oh wait, no. Just for the 1/2 is only for the even ones and not the odd.
Ooh, did you see what he's looking? If I take my paper and I line it up here kind of towards the middle, I can see that there's like a line here for the 1/2 for every other fraction bar. And then Julian went a step further and said the denominators for all of those are even. So all of the even denominators can be split into 1/2. Yeah. Just try your best. Equivalent. That's a great observation, Julian. Does anyone else notice a pattern? Yusuf?
I kind of heard this from Cardi, but the squares get smaller every time, like they go down.
Ah, yeah.
And the bigger the number, the smaller the square.
Yep. And we talked about that, right? When we're cutting our cookie into pieces to share, the more people you have to share with, the smaller the piece is going to be. Yes, Lawson, what else?
This is probably like it kind of points this out, but like each bar there becomes there's one more line.
Ah, one more part for each one.
Yeah.
Yep. Or when, if you wanted to be really fancy in math terms, we would call this a partition. Each line or each fraction bar is partitioned into one more piece. This little line separating it is technically called a partition. Yes, Mason?
All of them are cut to be equal to each other.
Oh, they're all in equal parts. That's a really important fraction concept, right? We can't cut this one whole into like one piece and another little piece, right? And then a random piece over here. We can't call that a fraction. It's got to be divided into equal parts. Cody, what else?
Is that why when there's factors like 1, 2, 1/2 goes into all the even numbers? Like the trick says that at the end, if the last number is even,
Yeah.
then it's a factor
Yeah.
too.
Yes, you can use that same trick for fractions. Yep. Yes, Sammy?
I think another pattern would be, I don't know if this is really a pattern, but like if you took away all the fractions and like the colors and stuff, all the lines would line up to be like kind of a pyramid shape.
Oh, if you kind of go like this.
Yeah.
Yeah. Mm-hmm. Kind of like a mountain, huh?
Wait.
Yeah, I see it. Yep. What else, Lawson?
That's what I
What did you
did.
say about the partition again?
Oh, I just said that, like, so this little line, like this is called a partition. So, like, when you said there's one more line in each bar as you go down, each line is a, so if you wanted to use really fancy math terms, you would say each fraction bar has one additional partition, or is partitioned in, you can use that as a verb too, partitioned into one additional piece. It's just a fancy math word for line when we're talking about this context. Yes, Joseph?
So you notice all the odd numbers go to the middle, and you'll actually see there isn't a line there. It's
Right.
just a number there.
Yeah, that's what Julian said. It's only the even numbers that have a line in the middle, a partition in the middle.
Yeah.
Yeah, because they can't be divided by 2, right?
Yeah, and also they're all two June, 3/3, 4/4,
Ah.
5/5, 6/6.
The numerator and the denominator are the same when you get to one whole, right? Yep. Because if I had my candy bar and I cut it into 9 pieces and I ate all 9 pieces, I would eat one whole candy bar. Yes, Barrett?
So it's kind of weird, but the partitions like break into bigger pieces each time. So like on the 12 and 11, they're like really close to each other, and then getting a little farther,
You're right.
and then same amount, and then farther.
So what I hear Barrett saying is if you look at the difference between the 11th and 12th, it's pretty small. Like a very slight difference, but kind of like Sammy was saying as she noticed it, it's not really a pyramid, it's more like a mountain because up here they get like farther apart.
Yeah, and then you have to go like this. It's kind of like this.
Yep. Like a mountain.
It's like a slanted mountain.
Yes, Lawson.
If you notice, like it's a color pattern.
Ah.
Red, dark blue, green, light blue, purple, kind of purplish, violet.
So they're sort of using variations of red and blue and green, huh?
And then it goes down, and then you get red again, and then the dark blue. on top.
You could predict that they would continue the same pattern. The next term would be
1/13.
and green. Yeah, good pattern. Yusuf?
I know this could happen sometimes, but on this, like, on the side, I guess, on the right, when it says, like, there's, like, 9 9 and 6 6, there's 2 of the number, but for the 1, why is it just 1?
Because it's just one whole. It's not a fraction. Because remember, a fraction means you've cut that whole into parts. And this one hasn't been cut into parts. I mean, you could technically have 1 over 1 to say that there's one part that makes the whole. Yeah, but it's sort of redundant. Yeah, so what are all these? I have one question before I call on you, Sammy. What are all these little fractions called that have 1 as the numerator?
Unit fraction.
Unit fractions. Now we have our new poster up here that's going to show us the unit fraction. It talks about how you can use fractions to write them as a sum, which is adding, and a fraction can be written as a product, which we'll talk more about. Yes, Sammy, what else did you notice?
I'm already out of space, but I said like it's just the same exact bar, but every time it's like split, it's in a different color.
Yep. Good observation, kind of like Lawson was noticing. Yes, Lucas.
Not really about this, but about the Empire State Building. I think my grandma works for the Empire.
Oh, cool.
She works for the Department of Justice.
All right, so we're going to start our sum of unit fractions tomorrow. So today we still have 10 minutes left until recess. So what I think we'll do is pack up your unit 1 or volume 1 book. So you can pack those up, freeze, listen to all the directions. Be real careful to make sure you're keeping your volume 2. So once you pack up your volume 1 in your backpack, then we'll work on star strips. So we can finish up those multiplication star strips. Sound like a plan? All right, so put your pencil down. Don't do that, Paige.